In the first quarter of the 21st century, energy was largely taken for granted. We had slowly forgotten how extraordinary it actually is. Human innovation, however, had helped us to harness this energy and use it to power our society, providing heat and electricity to our buildings, our schools, our homes, and our workplaces through the conversion of fossil fuels. A sharp rise in demand of this energy has led to mass emissions of greenhouse gases that have led to global warming. Scientists agree that a marginal rise on global temperatures, even by 2%, have unprecedented impacts on our lives. For us to stay within the safe limit, we would have to reduce these greenhouse emissions by over 80% by 2050. It might feel like a long way off, but the scale of change required, we need to act now. We would need a careful balance between supply and demand while supporting economic growth. Such an undertaking calls for flexible innovation in the energy sector. Innovation that will produce practical, low-carbon ways of producing energy. So what are the options? Let's take electricity, for example. Currently, most of our electricity supply comes from fossil fuels that produce greenhouse gases. But of the three significant technologies that combined can produce sufficient low-carbon energy solutions, the first, known as renewables, means converting sustainable natural resources such as sunlight, wind, and tides into usable energy. Benefits to the general environment and industries such as aviation, manufacturing, transport, agriculture, and even shipping are immense, leading to a greener world which can benefit hugely from a supply of energy that is affordable, secure, and sustainable, ultimately helping us to shield from the effects of dangerous climate change and price volatility. But on a global scale, how can we realize this clean energy for ourselves and future generations to come? Space-based solar energy, also known as space solar power, will generate off-world energy by placing solar power satellites in orbit. These would receive sunlight before it hits the Earth and would wirelessly transmit their collected energy to a receiving station on the ground. For safe operation of this groundbreaking method, Helios Energy has developed wireless power transmission frequencies that are eco-friendly and do not cause any harm to animals, plants, or machines caught in the beam. Solar power satellites are immune to cloud cover, to the changing seasons, and to atmospheric haze. In a geostationary orbit, some 38,000 kilometers above the Earth, they are also largely unaffected by nighttime shadow. Solar power satellites, therefore, are many more times more efficient than ground-based solar power installations. Designs for the conversion method employed in the transfer of wireless solar power from space to a receiving station on the Earth's surface were first developed by an American engineer named Peter Glaser, who in 1973 obtained a patent for his methods and apparatus for converting solar radiation to electrical power. This envisaged solar power satellites with microwave antennas that would transmit power to large Earth-based receivers called rectennas. Since Glaser's patent was granted, a lot of research and development went into the realization of this, and ultimately leading to the revision of his patent and issued a smart patent currently acquired by Helios Energy. Based on the now classic solar power reference system developed in the early noughties by NASA and the US Department of Energy, one of the very large arrays of photovoltaic solar panels are coupled to a microwave power transmission system. The architecture requires a large stabilized platform that rotates on 3 axes to keep its solar panels pointed to the sun and its power transmission dish targeted at a receiving station on Earth. Helios Energy are the pioneers of this method of interstellar harvesting of solar energy and have noted the vast potential expansion to other forms of energy by better utilizing the current grid of nuclear power plants, for example, that will see the use of helium-3 as a more efficient raw material used in nuclear fusion that generates electricity without the devastating footprint of nuclear waste. Space-based solar power has revolutionized the way in which we generate the much-needed electricity to meet the growing demands of the population on Earth. Space-based solar energy, also known as space solar power,